Welcome to RPS Group of Schools online classes. This is session 2 for the chapter Motion and Time. Let us have a quick recap of what we have learned in the previous session. In the previous session, we recalled the different types of motion that you have read in class 6. We also studied that motion can be slow or fast. We concluded that fast and slow are comparative or relative terms. In the previous session, we also discussed speed, its formula, and its units. Now let us try to answer this very simple question. Do all the objects move with a constant speed at each interval of time? You will see that there are some instances where an object covers equal distances in equal intervals of time. You will also notice that there are some other situations where an object covers unequal distances in equal intervals of time or equal distances in unequal intervals of time. So the motion of objects may be classified as uniform motion or non-uniform motion. Let us study them in detail. When an object moving in a straight line covers equal distances in equal intervals of time, however small the interval may be, it is said to be in uniform motion. Now, let's take the journey of this car as an example. This car covers equal distances in equal intervals of time. Here, each time interval is equal to 1 second and the car covers exactly 15 meters in each second of its journey as shown here. So we can say that the car is in uniform motion and has a constant speed of 15 meters per second. Now let's discuss some examples of uniform motion. Motion of hands of a watch, revolution of the earth around the sun, an aeroplane flying at a leveled height and at a steady speed, a train moving on tracks with a steady speed, a car moving on a straight road at a constant speed are some examples of uniform motion. If a moving object covers unequal distances in equal intervals of time or equal distances in unequal intervals of time, it is said to be in a non-uniform motion. Let us study non-uniform motion in detail. Case 1. The object covers unequal distances in equal intervals of time. In this case, each time interval is equal to 1 second, while the distance covered by the car in each time interval, that is, each second, is not the same. In the first second, the car covers a distance of 10 meters. Then, in the next second, it covers 18 meters, then 15 meters, 8 meters, and 22 meters in next each second respectively. Since the distance covered in each time interval is unequal, we can consider this as a non-uniform motion. Let us discuss case 2, where the object covers equal distances in unequal intervals of time. In this case, the distance covered by the car in each time interval is same, that is 15 meters, but the time intervals are unequal. During its journey, the car covers 15 meters in first 2 seconds, the next 15 meters in 5 seconds, then again it covers 15 meters in 1 second. Then it takes 4 seconds to cover the same distance, that is 15 meters, and covers the last 15 meters in 8 seconds. So it covers equal distances, that is 15 meters each, in unequal intervals of time. So we can consider this motion as a non-uniform motion. Now let's discuss some examples of non-uniform motion. Motion of a horse on a racetrack, a car moving through a crowded area, motion of a train about to reach its destination, and an athlete running in a marathon are some examples of non-uniform motion. The overall speed of an object having uniform motion is its actual speed, whereas the overall speed calculated in case of an object having non-uniform motion is the average speed of the object. Average speed is the mean or average of all the speeds of an object in a non-uniform motion. It is calculated by dividing the total distance traveled by the total time taken. Now here is the formula for calculating the average speed of an object. Average speed equals to total distance covered divided by total time taken. Let us solve a question in order to understand how the average speed is calculated in case of non-uniform motion of an object. In a 5-hour journey, a car covered a distance of 60 kilometers, 45 kilometers, 80 kilometers, 55 kilometers and 50 kilometers in first hour, second hour, third hour, fourth hour and fifth hour respectively. Calculate the average speed of the car. Now let's discuss the solution. Here, distance covered in first hour S1 equals to 60 kilometers. Distance covered in second hour S2 is equal to 45 kilometers. Distance covered in third hour S3 is equal to 80 kilometers. Distance covered in fourth hour S4 is equal to 55 kilometers and distance covered in fifth hour S5 is equal to 50 kilometers. So the total distance will be sum of all these individual distances. The total distance will be equal to 290 kilometers. Total time taken as mentioned in the question is 5 hours. Average speed equals to total distance covered divided by total time taken. Put the given values in the formula. Now, on solving further, you will find that the average speed of the car was 58 km per hour during this journey. That was all for today's session. Thank you.